right, in this video, we're going to take a look at U substitutions with definite integrals. Basically, it's going to work the same as we've seen before, except we need to be really careful with the limits of integration. If we're changing the integrand to be a function of U, we need to make sure that the limits are also limits of U. So I'm just going to work one quick example to show you what I mean by that. Say we got this integral right here. You got options. You could try to do a U sub, or if you really wanted to, you could do x minus 1 times x minus 1 times, well, you don't want to do that. It takes too much time. So typically we would let U be x minus 1. So du is going to be dx. And so then we would think, well, this would equal u to the 4 du, integral 0 to 1. Actually not equal. So these are not equal to each other, because if you take a look at the x values, the first integral is going x equals 0 to x equals 1. If x is 0, is u also 0? And if x is 1, is u also 1? Well, when you plug a 0 in for x, you get 0 minus 1 to be u. So your bottom limit should actually be negative 1, not a 0, because we're looking at the u value. Now when x is a 1, u turns out to be 0. So once I change those limits, now these things are equal to each other. And then I can use my power rule, and then I can evaluate it, the top limit minus the bottom limit, and then I get my answer. So that's essentially it for definite integrals with U substitution. Now, another option you can do is just evaluate the indefinite integral, x minus 1 to the 4 dx. You get the indefinite integral without the plus c, and then evaluate at 1, evaluate at 0, and subtract. Or if you just want to avoid the back substitution, you can just change the limits of integration to match my new function. That's actually it for this video. Pretty short one, but that should give you plenty of information to get those answered, or those questions on Schoology answered.